Sorry, misclicked.
That's okay.
Because I want to end it. I have 2 sessions on my two. The other one was on a tablet. I was not trying to end the Zoom call on the tablet. Sorry
All good.
Hello.
Sorry for that. Like, misclick.
Yeah. Let's see. Mute this. Okay. 1 sec. Let me try to find a good image. Looking through. Like if you do lecture, okay. Okay, yeah. Lecture notes by week. I remember you'd show us that. And if you go to like, let's see. I guess I'll just share the screen though.
Yeah, you can share. You can share.
Right. Okay. One sec. Okay. Is it doing it?
Mm-hmm.
Do you see week 3?
I think you're sharing it, aren't you? Are you?
Here, hold up. I need to stop share for a sec. Oh wait, is it doing it?
Yeah, I think so. I can see week 2 PDF.
For week 2 rather?
Yeah.
See it? Okay. Yeah, anyway. So these things I'm talking about.
Yeah.
Do they execute in any particular order? Do they execute all at once?
Oh, it's fine. This 2 is fine. But usually MAR equal to PC goes first, and then PC equal to PC plus 1. It's just like if you are following by one sequence, whichever order it doesn't really matter. But usually start with MAR equal to PC and then PC equal to PC plus 1. So after this clock cycle, the point counter will move to the next location in the memory where you're going to read your code.
Yeah, it's a little bit confusing. I figure it executed all at once, and then the clock cycle happens and the change happens at the same time, I think.
Like
not really sure because it's kind of confusing how he writes the instructions or the those things differently, and also after the decoder, when going into the different instructions, you'll write it differently. I figured it didn't really matter too much. But,
so
yeah.
so in theory, like whatever was in there actually happens like the same time, because if you don't have a clock cycle, it's like wires are all connected. Okay, when you are doing this addition or plus, the wires are literally just connected. So after this clock cycle, things are gonna just change, and then they are gonna be the same value at the same time, and then next clock cycle comes in.
Yeah, that's what I kind of figured, that essentially these things happened at the same time.
At the same time. Mm-hmm.
Concurrently. Also, he was talking about when it came to, what was it? I think it was H. I don't quite remember the letter, but it was the one where it was about the number of cycles. And I don't know if you'll be able to answer this, but he said when it comes back around, don't forget the extra cycle, and like don't forget to count that. And I was a little confused by that because I figure, I don't know, I was just, maybe if I can try to word this better, but
so let's just stop here. This vault, okay, never mind.
Let me see, maybe I can try to bring up a better diagram. I know there's better diagrams on.
So could you go back to week 2? Let's just use the halt as an example. I don't know what exactly he talks about when you have to add a count. I don't know exactly. Go down like to the halt instruction, or whichever instruction.
Oh, here it is.
Okay, let's say load, whichever one. It's fine. So did you see the line connect this wire to D1?
Yeah.
Right. This is actually the first flip flop, right? When you're starting the fetch. No, and then this also means the end of the execution.
Yes. I guess what I'm asking is D1, wouldn't that be considered like the D1 to wait for it to go through? Isn't that like an execution cycle?
Um,
If I'm able to ask that.
to be honest, I don't usually count it. Like the way I count, like I count clock cycles, I don't usually count it. You can send an email to confirm with the professor, see if whichever way was correct. Maybe I was wrong.
Yeah, I don't know. That was a little confusing. Maybe
Yeah,
I
you
need
can
to
send an email
reword
to
that.
him. Maybe
word
you
that
want to
better.
CC me as well. It says, okay, the TA says you don't need to count an extra clock cycle, and then you said you need to count a clock
I
cycle
don't know.
in class.
That was kind of something very specific. I should like have thought about that more and like wrote something, or maybe I'll just should ask him. But
Yeah, you can. I would say post on Piazza, see what other people thinks, or just send the professor an email, and CC me. Just tell him like whatever you told me, and then the TA told me was a little bit different. The TA doesn't count the one clock cycle. What do you specifically mean with that? You can send him an email like that. I think he will
I don't know.
answer.
I just remember him saying something about an extra cycle, but I figured like
Okay.
Yeah, Shane, I think all of us are confused about that. He did mention.
I'm mainly, I guess the main thing I'm confused about is where exactly the cycles begin and end, because that's a little bit confusing. I think I understand where they begin and end, but I'm not exactly sure.
So the way I anticipated is like the line says go back to D1, which means like a new clock cycle. The end of the execution of this instruction, and then the beginning of the next one, which it happens to be the beginning of the D1, right? Where after D1 you're doing the MAR equal to PC and PC equal to PC plus 1. So which you already fetched the instruction.
Yes.
So the way I counted, I started with D1, which is the first flip flop, and then ended with like before the line that says connect to D1. I would consider that as like a whole fetch, decode, and execute cycle.
If you get an answer from the professor, could you share it with the whole class?
I would have to, yeah, I'm gonna have to think this.
Yeah, like you can just make a post in Piazza. Once you ask him, you can just share within the
like
Piazza.
explaining. I guess the question is kind of like explaining the exact like beginnings and ends of the fetch, decode, and execute cycles, because that's not really asked from the homework. It's more like how many cycles, and I understand that, but I'm just a little confused on.
I don't know if
exactly where
if
the
I have
beginnings
mentioned
and
this.
endings are.
I think I've said this before. The ending of the previous instruction is the beginning of the next one. It's happening the exact same time.
Yeah. I'm just like, I think I might be off by one is what I'm saying.
Also, you know how I posted I posted it about the clock cycle. That like I was like it affects the clock cycle if we do add an extra flip flop for the load, and then how the PowerPoint doesn't match professor's drawing, and you
Also refer to the PowerPoint.
You answered it, huh?
Refer to the PowerPoint.
Okay.
He might be misdoing something.
The professor has changed the design, because I've looked at like various like things, and the design I think was changed over time. Because I think one change he did is he did the if I go back, he did this like one change where he added in the MAR equals whatever, like he added that change in somewhere to like eliminate one of the flip flops.
Yeah, I remember that too. So I think that doesn't do anything with the load though.
Load. No, I remember the load it had like 2, I think, back in the 2017 slides, and then because he did it like that, it
Yeah,
eliminated
and
1.
solution also. So like basically, from my understanding, and when I asked around from some engineers, they said that you do need a flip-flop, and the TA also thinks that's how he drew it in the presentation, and that's how it is in the PowerPoint. But then the professor didn't draw it. But when he was saying it, he said, "Don't miss the cycle." So this is where he said include going back. So like, it wasn't clear, man.
Okay. Just don't worry about it. To be honest,
The machine
it's not that big of a deal. It's like just solely depending on how you design the load, right? How you design the load instruction to be executed within the flip flops, right? I would not be taking points off for this homework. And then if you want to double check with the professor, because like I think I'm right, okay? And then he's been teaching that before as well. If you check his previous year's lecture videos as well, he might be misdrawing or something because I'm not following his lecture, to be honest. I would not be taking points off if you miscount for that particular load or a clock cycle. Just don't worry about that.
Perfect. All right, thank you. Also, I have another. I have 2 more questions. If that's okay.
Yeah, go ahead. I think then the rest, like I've done my talking, because like we don't have a new homework coming, so this is just basically it. I'm just gonna be answering questions, course materials or homework questions.
Okay, so for the homework, for part D, where we have to write the table, I noticed in the homework solution there's this drawing that shows like the opcode position and then the next location and
I think
stuff.
you need to do that. Yeah.
So I thought only having having the same table as the PowerPoint is enough. Do you want us to draw the extra drawing?
What was they said here? Tells us to specify the opcode and the address for operand fields. Yes, you would need to do that. It's
format.
Set. So in part C, it says very specifically specifying the opcode and the address and the operand field. So which bits are for what?
All right, I got
If you don't want to draw it out, you should tell me, okay, from bits 6 to 15, I want it to be what?
Okay.
This instruction, yeah.
And then, for the 4 instructions we add, the one thing I'm scared of is that I'm not so sure.
Just be easy on it. It's fine. Like I think everyone is so stressed out about it, and people ask me about what they can do with it. You can do anything. Tell our instructions that's reasonable. Just don't tell it. Okay, it's an instruction that does nothing. I just don't want to see that because like you're just not paying, not doing work.
Instructions, okay.
Just do anything. Just do anything.
The only thing that I was worried about was that, you know how for like move and load, we have extra flip-flops. How should I know if I need extra flip-flops for like my specific?
I wouldn't know. Like I would say design something trivial. You can say, okay, for example, you can say increment by 2, okay, something like that.
Okay.
You're not limited of what you can do. Just don't really overcomplicate the problem.
You can design. I think they have to do with like memory access, stuff like that. Like there's memory registers when you're writing to them or reading from them.
Yeah, exactly. Like I think that's exactly the time you need to add clock cycles when you're dealing with the memories. Like other times, like simple instructions like increment and stuff like that, it's usually just one.
What about rotate and carry? Like something with having
this part of it?
No, I'm adding for the extra.
Like I said, like if you rotate and carry, might depends because it could be a for loop.
Rotate and carry.
Like I said, don't overcomplicate things. Like if you want to think about it, you should think about this like process yourself. When you say rotate, what exactly do you mean rotate? You want to rotate all bits or rotate X number of times? It might need a for loop. If you're dealing with that, you would need a lot of more extra clock cycle, which I can't just describe it over here.
Oh my god. But multiplication and division and stuff, those.
Yeah, I think multiplication as well, it's gonna be a little bit more complicated.
Wait, do we have to design the proposed commands? On part part I, last part? Because I think I remember reading a Piazza post and you just said to like add them to like the decoder and then just explain, kind of like in.
Yeah, you just put them together.
Ah,
It's
right,
basically
right.
tells you to put them together. It's fine.
Oh, good, good, good. That'd be crazy.
Just let me put this again. So clock cycle is just tell you where exactly to multiply things, and then when you're dealing with very complicated instructions, one way of doing that is you can put things in the code, and then you actually execute it in the VASP, and you will tell you how many clock cycle it actually does.
Yeah, also the flip-flop thing, like whether there's an extra flip-flop or not, is kind of arbitrary. Like I think that this is kind of like
Yeah,
just a
like yeah,
concept.
I would suggest just don't overcomplicate things. Just don't design something that's too
Yeah,
hard.
I don't think that thing about the flip-flop necessarily matters whether he's forgotten one or quote forgotten end quote, because this is sort of just like a concept of how a computer would be constructed. But let me see here.
So how do I know if what I'm choosing is too complicated or not?
It's like taking you more than half an hour to do things. It's overcomplicated.
If I have an add with carry, would an and be enough? And gate?
I think maybe and or.
Uh,
ALU itself is just basically AND gates and OR gates. Maybe a NOR gate, a NOR gate. That's it.
okay.
That's digital logic design. It's 244, right? Is it?
Would you suggest us just change up the instructions we
It
already?
depends on you. I have no control over you. Do whatever you want.
I know. I'm just saying. What do you suggest?
Suggest doing something easy, trivial, which is similar to the instructions before, and then don't like increment by 2 instead of increment by 1, and then you can do any other things like that, simple like that.
And for example, increment and skip if 0, this also works. Increment.
Something like that. Something
Yeah.
like that. Yeah.
Thank you.
Don't overcomplicate things, because I don't want to be seeing like people want to do the for loop in one of the instructions, and then I have to make sure you're doing the right clock cycles. I don't want to count that as well.
Okay, so can I double check something? I don't want to be like copy pasting and stuff, but like when we have an instruction that it's like XOR, like XOR, like XOR, is that the gate I need to use when I'm connecting the fourth output of the flip-flop to the instruction from the decoder?
What are you asking? I'm sorry. Could you?
So like, you know when you have a decoder and then you're connecting to normally we have seen AND gates. Would I replace the AND gate with like OR gate or XOR gate?
Why?
Because the instruction says like XOR or not?
The AND gate out of the, you're saying like whatever comes out of the decoder, you want to replace that gate with an OR gate? That no, you cannot. That should always be the AND gate there, because that's the only time you execute this typical instruction. I don't know if we're talking about the same thing.
Yeah, we are. So for XOR, I don't do anything. That's it.
No, you do XOR after that. No, the logic. Like I think you're confused here.
Yes.
Hey, for the homework, for any particular question, did we have to worry about like implementing the flags in any of the designs, like in the
just specify like when you're doing something new, just specify. When you say, okay, I have a Z flag, what does Z flag mean? Usually it's 0, but if you want to change it to something else, you tell me, okay, what Z flag is. Like I would assume you have the select S flag, which is a select bit. Since you have the exact, exact bit it is for the for the instruction of the select bit, you can say, okay, I have the select bit because I know exactly which bit in this instruction is. That is the S flag. Basically, in the real world, you just connect that line with that bit, okay, and then that you can call that line. You grab it and tell, okay, this is Xiaomin. This is S flag. This is a select bit, same as the right bit or the right flag and then load flag or save flag. It's the same. something new you want to introduce, let me know. Put it in your comments. Just okay, this is blah blah blah. Okay, D. Let's say you have a D flag. What does D means? What does this flag represent? And then where did you get it? If you want to do something like that. If it's something like normal, like Z, which represents 0 and represents negative, as it represents select, I will usually know.
Yeah, I didn't do the format thing in the table. I just put like the representation of like, I put like the type of each bit and like a thing below it, and I like explained a bunch of stuff.
That's good enough. Yeah, I think that's good enough. Yeah, as long as I know what's going on. Otherwise, like I can't make sense of it, right? Just imagine something that's not from engineering is looking at your homework and then try to make sense of it. What would he be looking for? He'll be looking for explanations, right? Like just what do you mean by S here? Like I'll be looking for things like that, right?
So for part D, when we're designing that in Circuit Lab, because we have that selection bit, which determines which register the output goes to, I've just been ANDing that with whatever the output of the AND gate, say for like the add instruction, I've just been adding 2 AND gates to that and having 2 different possible outputs.
Yeah.
Is that okay to do it that way?
Yeah, because I think I talked about it in one of the quick office hour after the class last Tuesday. I think that's exactly what I did.
Okay.
It's also recorded if you want to go and check it.
Maybe go over, I know like we're short on time, maybe we could go over like part D and like how you did it and stuff, like how you drew it out. I've been really lost, like if I'm being honest.
Maybe only show like one of the.
Yeah. I will open up the Zoom on my iPad. So
Okay, thanks.
Wait, can you show like something like or like IOR and XOR ones?
this is recorded, right?
Yeah.
Okay, give me 1 second. Okay, actually go back here. Why not? Okay, let's say you have an instruction that you want to do over here, right? This is your decoder. Whatever you done was from here. Okay.
Oh,
And then you're gonna end this, and then let's say this is your S signal, right? And then you have an X signal which connected directly with an AND gate. Let's say it performs A equal to A plus 1. And then you have a NOR gate. If you could mute, there's someone else talking.
oh, pardon me.
Thanks. And then there is a NOR gate connecting directly to this S flag. And then you can connect to another AND gate, which performs this, and we call this a select. And then the things that's right here, okay, let me draw this more clearly. The things that performs right here is a 1x2 decoder.
Why do you have an A and a B? Like, why do you have A plus 1, B plus 1? Can't you just use like A equals A plus 1?
It's like you're selecting, because aren't we talking about select bit design?
Oh, you can either select whether to increase A or increase B.
Yeah. That's like the whole purpose of here. And then this is a decoder, right? This is like here is the same. You're selecting which instructions you are doing, right? Here you are selecting which A or B is performing.
Oh, I see. And then what's that thing connecting? What is that? Are those all the flip flops? Like flip flop 1, 2, 3, and 4?
Which ones? Like right on top or on the bottom?
On top. That big box on top.
Oh, this is like the decoder we talked about. This
with all
is
the
just
flip
regular
flops.
decoder. No, flip flops are over on the top.
Yeah,
Like
that's what I'm saying.
Yeah.
All the
is
flip flops are on the top.
Yeah, I just don't want to draw it.
Oh, was
Getting
that what we're
lazy.
supposed to draw for homework? Because I drew something kind of
Yeah.
Yeah, I didn't know that we had to like have a select bit for A and B.
I think it was in the homework as well. It tell you to do a select bit.
Oh crap! I guess I can try and fix that. I guess.
All right.
Okay. Thank you.
You forgot something.
What?
I thought you were gonna show like what XOR looks like.
What?
XOR, the instruction on your drawing.
No, I'm showing increment. I'm not going to show XOR. You can do it.
Could you show it, please?
No, I'm not supposed to tell you how exactly the homework is, or how I'm not supposed to solve it for you as well. I'm supposed to tell you the conceptual level of things and then how this could be. Sorry for that.
You know when the next homework's gonna get released?
I don't know. I'm curious as well. Probably next Tuesday.
Well, thank you for Thank you.
Yep.
So it's like discussion or something. I guess we've been having discussion.
This is it. What do you mean? Like
Or I mean office hours.
Yeah,
rather.
this is the rest is just gonna be office hours. I'll be here just answering questions till 4.
Thanks, gentlemen.
Yeah. Oh, I thought someone has a question. Or did you just say thank you?
I think you said thanks. I'm just trying to think if I have
Yeah, like just
question.
figure out your question and answer it. Like I ask it. Sorry, I'll always be here till 4. So don't be like stressed out or like there's a time limit. No, it's fine. You can be here and then prepare a question and ask. Like I will be here.
All right. Yeah, I'm gonna be back in a little bit.
Yeah, and then I'm cool with discussing class materials that you have concern with. You can also share your screens to we can discuss some stuff. I'm cool with that.
Yep.
I wanted to clarify like where, and I guess like the size of PC, IR, A, and B. So are they all like the full length of
Yeah.
like 16 bits also?
So there are also registers as well.
Yeah.
The same size as A or B, because you know, like I think I talked about this as well. Like when you remember, like your computer is usually 32-bit computer or 64-bit computer, right? What does that mean? When you open up your computer and then property, you can see that. What does that mean? It means like all these can be maximum 64-bit.
Mm-hmm.
And then each one of these should be 64 bits so that we are loading things into that you are not missing information. We are missing information, your computer is going to crash, right? It doesn't know what everything goes. Let's say when you're running a 64-bit operation in your 32-bit computer, it's not going to run. It's because it's not having a consistent size of MAR or PC or register A or memory as well, like one of the memory location, right?
Mm-hmm.
It's collapse. It's gonna collapse.
So then like, if you knew that your opcodes are like a certain length and like, why would you not just have like your IR be specifically just the length of everything else as a, like, and not include the opcode? Because like, or I guess you would need the opcode. Never mind.
You would need the
Yeah.
opcode.
Okay. Yeah.
And then like let's say for add just opcode 0, right? The rest of the bits is useless. You
Mhm.
can put anything in there. It doesn't matter. Once you see that, you're gonna just add register A and register B, right? The rest you can put anything in there, but it doesn't matter. But this is how the length is predefined. The length of the add operation is predefined. It's always gonna be the same as register A or B or MAR or PC. It's always gonna be, let's say we predefined it like 16 bits. We only need 1 bit to tell it's a 0, or 4 bits to tell it's a 0. Let's say we usually dedicate first 4 bits to opcode. So first 4 will be 0, and the rest 12 will be anything, but you don't care. right? Because that's predefined. It's just what it is.
So then in the drawing that the professor drew like at the very beginning, like drawing like the block of memory, and then he drew like the side like next to it is IRPC A and B, and then the ALU, right? So then if like is that like where, how does that look like in memory? Like it's completely separate from your memory block?
Which ones? Like the memory? You're only
Like
talking about
IRMP, like IRMPC.
no, it should be different. I think this is something I also talked about in this class. It seems stupid to put the registers and the memory together, and then you call when you are calling the registers, let's say the A, B, and I, or PC, or AC, or accumulator, you're using a memory address to call them, but in real life you should not. They are in different physical space. Registers are usually resides in the CPU itself.
Oh, okay.
Memory are the hard disks that usually you store your games or your movies and stuff. So they are in two different spaces. It should not be the case, and it's fairly confusing, to be honest. I called it stupid. I think I even said it in one of the recitations. I called it stupid, but this is what it is in this class. Like you're just using that way to demonstrate usage, and then it's just the way the professor writes the simulator, like the VASP, the very simple machine.
Okay, yeah, that makes sense.
I have a question.
Yeah, go ahead.
So you only need a select bit for some of the operations, but so in the ones that don't need it, is that one bit just a don't care?
Yeah, you just don't do that. Do that the same way that like in the class or in previous homework solution.
Okay, thank you.
Wait, what was just being talked about?
No, like she was just saying what if the one of the operations doesn't need a select bit? Then just don't do it.
Right. Anyway, should we have any outlook on like push pop, the stack, that kind of thing?
For now?
Yeah.
I wouldn't. Guys, this is too far ahead. Like we're not even talking about that.
Okay. Yeah, I was looking up stuff and stuff like that.
But I think you can definitely read through that, and then if you're confused, go through some YouTube videos. They have fairly good explanation on those.
Also, I don't know if I should say this, but basically, I did this like kind of cool trick where I was able to get more like usability by effectively reducing the memory address locations to 1023 instead of 1024, and paying attention to whether the memory address bits were 0 or non-zero, and using that to determine like if you're moving from a register to memory or not, that kind of thing.
Okay.
Memory to register, memory, etc. Register, whatever. I don't know. Just trying to think if I have any questions though. My main thing was that like the sequence, he was like really confusing on.
I also checked with the professor. I think I tried to explain, but there still might be some confusion after I explain. So I think the best way will be consulting the professor, because I don't think you can get definite answer from my side.
Right. Let's see. Go through what I have here.
So for D, where we use the selection, I was a little confused on that. Sorry.
So they're saying like when you are doing some operations, you need to select which register you want to perform the operation.
For example, for
increment, like the one example I just showed you is increment, right? You want to increment register A or increment register B. It doesn't tell you, right? You have a select bit, so you're just doing exactly what I did previously to just do that.
I see. So I need a selection for that, for increment.
Yeah.
And for subtraction, what about A minus B? I can do it like in the answer sheet. What I see, just it says
Yeah,
A is-
yeah. Just
A is equal-
explain it. Yeah, you can do whatever you want. Just explain it.
I see.
You can say the subtraction will be A minus B, but where you store it. You have this selection bit, right? You can say, okay, I'll store in B if select is 1. I'll store in A if select is 0. You can do whatever, but just sort of explain it. Just let me know what's going on.
Selection. Okay.
Yeah.
And for the I see. And for the last one, just I have to make a drawing only for the one which extends the 4 and
Yeah.
more extra.
Yeah,
Only
just draw on top and then just add the 4 after what you have drawn in C.
I don't have to repeat again that one, right?
Yeah, I don't have to.
I see. And one thing now, sorry, yeah, on the on E, when we do the drawing, we have to show the selection. Also on the when we're on E.
You mean D or E?
E when on the graph.
Yeah, determine the number of clock cycles you need to do that for each one of the instructions.
Yeah, just like in the answer sheet, right?
Yeah, yeah.
I saw the drawing and I make the connection,
Yeah.
right?
Yeah.
Okay. Okay, thank you.
You're welcome.
I scanned, I don't know if this matters. I tried out Circuit Lab, but it was like taking long for me to like put everything together. So
You can just draw it. I would just
yeah, I
prefer it
drew
that
it.
way.
I
You can just draw it.
took nice quality pictures. You zoom in if it's like
Cool.
can't read it.
Use Cam Scan. Oh, I forgot to mention. Use Cam Scanner. There's an app called Cam Scanner. It's free to use, and you can scan your homework into PDFs. It does a very nice job.
Yeah, I use something similar. It's like Adobe Scan, and
Cool.
I recrop it.
Cam Scanner will do the cropping for you. Just to let you know.
Well, yeah, it crops it for you, but I recrop it because it usually like cuts out the end bit.
Cool. Very nice. I'm looking forward to read your homework. Submit it on time because it will cut off. Like I will not take late submissions.
I already submitted it.
Yeah, you can submit multiple times. I don't know if I allowed, but you can. I think you can submit multiple times.
Yeah, I submitted it a few times because I like messed something small up.
Yeah. I always believe me, this homework as well, as professor mentioned a few times, don't select late. There's gonna be 1 or 2 students gonna come here and say, okay, I select late, just 10 seconds late. And then there's some problem with my internet. I cannot submit. Please give me this chance. And then they will email the professor. I've seen this so many times that there will always be 1 or 2 students doing that. Please. Everyone's in here, please submit on time.
Yes.
I have another question.
Yeah, go ahead.
So the way that I interpreted the problem was that like add and subtract were performed on, so add would be A equals A plus B. So for when we designed the 4 more, I made one that was like add B, which makes B equal to A plus B. Is that okay?
I think that's fine. It's fine.
Okay.
That's fine.
Yeah, I changed one of the professor's preferences on the jump commands because his jump 0 command was if like the register or whichever register is equal to 0. And I don't know, I thought that was like maybe a little silly, so I made it where if both registers are equal to each other, and I kind of like made a lot of little changes like that. But I don't know if that mattered because like I looked at the lecture after I made those changes where he was talking about like jump 0 or whatever. Or I made that before, I don't know, whichever one. Yeah, you still there?
Yeah, I'm still here.
Also, the homework is out of 100 points on canvas, but it's 80 points on the.
I'll make sure
worksheet.
to change it. I'll make sure to change it. Thanks. Good point.
Do we get like 20 extra, 20 free points?
No. I'm grading pretty loosely, so don't worry about it.
Hey, Shaman, I have a question regarding part D as well. So the select bit will decide where the sum or slash all of those commands will go to, right? Either A register or B register. So while writing them down, I wrote A equals all of them and then made a simple statement which said if select bit equals 1, then register goes, the assignment goes to register A, or select bit equals 0 goes to B. Does that work, or do you want me to write an if statement again and again, like for all the instructions?
Can you do the way I just performed? I don't know if you were in the session or not, but can you just do the way I performed? Just put a select bit there and then put a I wouldn't say decoder, but put a line and the NOR gate for you to select which instruction you want to do. If you're just writing if statement, like I don't think it's select bit it matters anymore. Like it's not the purpose of the design. You're trying to design it, not just write a code to accomplish it, right?
No, I'm talking about the instruction format, not about the part. So it's the opcode instruction and format, the table. I'm talking about the table.
What do you mean you're talking about table? I'm confused. Sorry.
No, I'm not talking about the design itself. I was talking about the table where I wrote the table, like the instruction down.
Yeah, that's fine. That's fine.
Oh, yeah.
That's fine. I thought you were saying in the design you want to write an if statement instead of like putting that AND gate together. Yeah, that's fine. That's fine.
Okay, thanks.
Because you were saying D, right? I don't know.
Yeah, the parts are like, so I changed the 2 C's to 1 C.
Oh, okay, never mind. Yeah, there's 2 C's.
Yeah.
I didn't see it.
Yeah.
Yeah, I just by default I just look at D. Yeah, there are 2 C's. Cool. Yeah, cool.
So I wasn't in the session right now, just to like confirm with the thing that you said about the E part as well. Like, is there anywhere I can see that, or
Yeah, I think the lecture will be posted afterwards. This is recorded. Everything is recorded.
so sometimes it takes like a lot of time to get posted with professors. I just like want to confirm before I submit the homework. Like I'm planning to submit by 8 p.m. so that I don't like have an internet issue at the end.
So you're talking about the clock cycle?
No, the design one, like what you said that you did in the session before. Like, is there a PDF for it or something that you whatever you worked on?
It's within it's in another Panopla recording as well. The most recent one. You can see it, I think.
Okay, thank you.
Yeah, no, the one that's 3 days ago. It's only like 9 minutes long. Check out that one. Like I think I just made one there.
Okay.
Wait, what's in that recording?
Just tell you how to do select bits.
All right.
Exactly what I just showed. It's fine. Like people keep asking. So.
Oh, there a video. Where is the select bit video? I want also to see.
It's the same one that I just showed you. The same graph I just showed you. It's the same graph.
Oh,
Nothing different. Yeah. You can take a look, but it's exactly the same.
Okay. And one thing for the G about the AND, it says that shows the design of a typical flip-flop in register A and the MAR. Can you give us a brief explanation? I will do it, but I was a little confused on that.
It's similar to what professors have done in class. And then I think I also talked about it last week. You can check out the video.
Okay. Last week.
Is it okay if we didn't have this select bit in
It's fine. It's
the
fine.
design schematic?
It's fine. It's fine. It's like when you have like a write bits and then like a load bit, the flag. like you're putting things into memory. Like how do you do that? I think professor talked about it in class. You can just use exactly the same graph that he used. He drew it in class. I wouldn't be really harsh on this one.
For for the one I asked you?
Yeah, to show the design of the typical flip-flop in register A and MAR. I think he have done something similar in class.
I see. Okay. Thank you.
Just curious, have you guys done the homework already? I know Sean must have done it.
Not yet.
Yeah, I just realized I made like a really small mistake, so I'm about to re-upload it real quick.
Oh, I'm done with the homework except like the last two.
Misnumbered something.
Cool. I'm just curious. Try to do it like you guys are doing good. Try to do it 1 week before the due date, at least. Okay, 1 week, so you have time to ask questions.
Yes.
If you're starting the last day, you're gonna mess some problems. Just be frank. You're gonna be nervous when it's near the due time. You're gonna be nervous, and then you can't produce much near the due time.
So for submitting it, my circuit lab diagram is pretty large. It's like gets a little difficult to see some of the details. So I'm probably going to upload it, scan it as a part of a PDF, and then also the individual PDF as itself, so you can like zoom in.
Not a problem. Cool.
Okay.
You can attach to the link as well. Maybe I don't know how you're gonna submit it. You can attach to the link as well, somewhere maybe in the PDF. I can just click the link and then just go into the circuit app and view it.
Okay.
If you could, but if you
yeah, I can try that.
Thanks.
For the format part, for part D, like the table, it's still 16. Like it's like for add or something, it'd be 5 for the opcode, 1 for the select, and then 10 for the don't care.
Which one are we talking about?
The table.
The table one, yeah. Could you repeat your question again?
Like I was looking at the example, the solution or whatever. And like something like add is 4 and then 12, but for this one, since it's like 5 for the opcode and then 1 for the select and then 10. Okay.
I think that's cool.
All right, thanks. Oh, also I was gonna ask, do we need to write the A equals A plus B or PC equals IR 4 through 15 like next to the format?
What do you mean format? Next to like flip flops, the design, or
like where in the table, like for part D, like you have the thing where like the column where you write like the opcode select whatever, how many bits that takes up, and then next to that it says like A equals A plus B for add, and then subtract is A equals A minus B.
I think that's enough. That's good enough. You don't need to do anything about PC unless it's like a jump, right? It's like something like that. You need to modify the PC.
Okay, so we do need to write that stuff.
Yeah, because like the whole purpose of jump is to, let's say, replace the point counter with a value in, let's say, register A, right? That's the whole purpose of jump. So if you don't write that, like you lose the purpose of it.
Okay.
In the IR, we will be writing 5 to 31, right? Or sorry, 4 to 31, because 0 to 4 and 0 to 31, that's 5 cross 32 decoder, right?
Mhm.
So,
I think I also talked about that.
yeah, so you would prefer 4 colon 31, right? Like I'm just asking in terms of like, do you want, are we counting 0 to 4 or 1 to 5?
Like if you put your select bits into bit 5, then 0 to 4, right?
Yep.
It
Okay.
just
Thanks.
all depends on you.
Okay.
You're designing it, right?
For the subtract, does it matter if you're doing A minus B or B minus A?
It doesn't matter.
So it can just be A minus B every time?
Yeah.
Okay. Clear just sets A and B equal to 0, right?
Like, what do you mean? It sets both A and B to 0? Like, does it need a select bit? You need to think about it.
Oh. So it can do either one.
I don't know. Think about it, okay?
Okay.
So design, I don't have to worry about the select bit. So I would have added it in if I saw that discussion video earlier.
Mhm.
I guess it's just if you were to add in like a select bit, I guess it would be like wherever the register bit is, and then it's like you know, after the and from the decoder, it's like you create an and for, you know, the low state of the register bit, and then one for the high state where there's a NOT gate preceding.
Mhm.
Like there's like a NOT gate, and it's like two different AND gates. And then I guess there would be like more letters or something like that.
Mhm.
More of a right. Yeah, I missed that like 10-minute video or whatever. I missed the select thing, adding in the select thing. So I don't know if that's like a big deal. I wrote like if it was like add or whatever, I wrote like A or B, like lowercase or equals A plus B, like if it was add. And so that's what I did for that.
I don't want to say it's correct or not, but you will see when the homework grades comes out.
All right. I don't know. Maybe I'll give that a redraw tonight. Probably take a long time though. Let me see. Is there any particular version of VSP VESP that we should be using? Like I noticed he has all these like different versions of it. Is there any particular one that we should use?
Which one? For this one?
For the course, like, well, like later in the
I
course.
think things gonna change. We're gonna be using different versions.
All right. Okay.
Like for the first one, it actually says like A and B registers are like in VESP1, so you're doing things like in VESP1, and then you'll be coding in VESP2, and you'll be changing code in VESP 2.3. I think that's how it's gonna looks like.
Right.
If you guys don't have more questions, I'll just end it here.
Wait, can I ask a couple questions about I joined this class like 2 weeks late, and I've been like trying to catch up just watching the lectures. But there's a couple of fundamental things that I don't understand still.
Okay.
Okay, one sec. I'm trying to pull up the discussion where you were talking about this. Okay, I guess the first thing is like for on the homework, part F, like the typical flip-flop in register A, that kind of thing. Is that like transferring the data from one register to another, like one, like is
To the
that
other. Yep. It's
like-
transferring the data from one register to the other. Yes.
like when you do PC equals MAR or something like that? Like that's what that is. It's just a diagram of how the data.
It's a little bit different. It's like for each one of the elements, you're transferring from one to the other, and
Okay,
then
that
you would
makes
need
sense.
like writes, flag, and then stuff like that.
Okay, but like essentially that's like what it's for, is to like.
Yeah.
Okay. I had one other question too. I just want to look really quick. Okay, yeah, another thing I wanted to ask, what actually is like the instruction register? Like, is that,
It's just
is that,
one of the register like A or B.
so it's not where, so why do you use it at all? Like, why do you, if you're gonna put the operand or whatever, like for the load instruction, if you're gonna take an operand and put it into like
So-
register A or something?
Because
Why do
like you want to load it first. So when you because A or B are constantly modifying, right? You always change the values in A and B. You want to be a place to store that value, and then it doesn't change that much.
Okay.
You can think about it that way.
So
And then you can use the values in the IR, the instruction register, to do other things. When, let's say later, we're going to do decoding, okay, to determine which opcode you're running, right? If you put in A is going to be changing every time. Anything you do is basically on A, right? So you don't want to do that. You want to put it into somewhere safe, It's like putting something on the side. You putting the IR register on the side. Whenever you want to access it, you access it.
Okay. And then also, okay, so the program counter, like PC, that's like, it's pointing, it's an address of somewhere in the memory, right?
Mhm.
And it's pointing to the, like, one thing in the table of opcodes that has like whatever, all the different instructions.
Mhm.
Okay, so that, like, is that, you're like assuming that the table of opcodes is somewhere in memory, like in order, so you can just go through it?
Yeah. Yeah.
Okay. And then, so it's only for the like load instruction where there's something on the next line that you increment it, right? Like you don't just increment it every time.
No, you increment it every time, because that's like when all your instructions are stored in the memory, right? And then when you're running your instructions, you're like, this point counter is going to keep going to the next line.
But doesn't that mean you're just like, you would do everything, like every single thing in order then?
Yeah,
If you run-
what do you mean? Yeah, you're doing everything the same in order. Yes, that's
Like-
always the case.
You just run the program and all it does is then like add, subtract, increment, like shift left, shift right, complement. It just does everything once in order.
I think we're not on the same page. Like, you're saying something different. What I'm saying is, point counter is something that points at which instruction you are currently running.
Mm-hmm.
Okay, and then the instructions, all the instructions are saved in the memory. And then when you are running your code, let's say when you write up some code and put it in the memory, you want to execute it, you go from line by line, and then the point counter go from line by line,
Okay. Well,
pointing at the address.
until that instruction's over, right? Like you wouldn't go from like the 2-line one, you have like the like for move, you have the source address and then the destination address is on another line.
Mhm.
And then after it does that, it's not just going to go to jump, right? You have to like,
Finish this first.
what's
You have to
that?
finish it. You have to finish this line first. Let's say if it's a move instruction, PC is probably going to equal to PC plus 1 within that instruction.
Mhm.
Since like move will need 2 instructions, right?
Yeah.
So within that line, you will accomplish that first, and then PC will go to the next one.
Okay. And then does it go to the next one after that and move on
Yeah.
to jump?
Yeah, move on to the next one. I don't know exactly what you're talking about, but move on to the next one. If the next one in the memory is jump, you will jump. If the next one is increment, it will increment.
Okay. So it does just go through like the whole list then.
What,
Right,
what
and
do you
like-
mean the list? This is different. You have a decoder to tell you which one to go to.
Oh.
I don't know if we're talking about the same thing.
Like you can't do them out of order. Like the order that you put all of the instructions in, is that the order that it's going to go through it no matter what?
I
And
don't know.
execute the instructions?
So the homework we're doing here, it just tell you, okay, whenever the opcode is for some value, it's going to decode it and it's going to do something.
Mhm.
It's not essentially saying, okay, I'm going to do add first, then subtract, then increment. No, that's not the case. Your instructions are somewhere else in the memory. I don't know. I think you need to study a bit more. I think you have some fundamental questions.
Okay, I guess that makes sense though.
Yeah, like the design we're doing here is basically you get the instructions somewhere in the memory. Okay, we're not doing memory design. This part here of homework 1 is nothing about memory. You're saying, okay, whenever we get something from the memory, how are we going to decode that instruction and then perform something Okay. That's essentially what we're doing here in homework 1. And how do we perform it?
Okay. That makes sense.
Okay, cool.
All right. Thanks again.
Yep.
Xiaomin.
Yep.
I just like after I left, I've been like rewriting the auxiliary move steps, and I'm just kind of confused. Can I share my screen?
Yeah.
So I rewrote it out like this, and I feel like I'm definitely missing something because at no point does it take the value of the array at I. Like it's increment, like I see the incrementing I part, but like, is it like, I guess I don't know what these values are, so maybe it's that.
Wait. What are these? 47. So 3YYY should be 0047, right? YYY should be 047. Right? Should replace that value by 047.
Okay, sure. So then that means that. So this is, okay, this is 3047. So then
Mm-hmm.
it moves. So 0047 is going to be equal to I. Like just the value at I, or is it like, because this is
No,
saying,
just fundamentally what it should be. Should be whatever the value in 02, right? Which is the value of I,
yes.
correct?
Mm-hmm.
Then what?
So then that means that in the next step, then B is going to equal I, right?
No, I is okay. Okay, let's assume I is equal to 00A initially. Okay, let's just write it down. Let's assume
Okay.
the value of I equal to 000A. Okay, what's the U gonna be here? Let's replace the U with the value.
000A.
Yeah,
Okay.
right? Is it? You tell me. You tell me. Is it?
Yes.
Okay. Replace the values. So what are we doing here?
So then you're going to take the value, B is going to equal the value at 000A.
Yeah, like
Okay.
what's in 00A? Go check it out.
A at I, or A at 1 or whatever.
Is it?
Array at 1, I think.
Is it? Right?
Yeah. Oh, okay.
Okay.
I see now.
Okay, cool.
Yeah, that makes sense. Thank you.
Yep. Ask away. Let's do here. Okay.
I'm working on that. Yeah.
Okay, you have more questions?
No, actually, I'm already doing that one. But already
Cool.
I clear anything. I will email.
Okay, if you have questions, put in Piazza. Don't email. Put in Piazza.
Oh, in Piazza. Yeah.
Everything put in Piazza. Cool.
Okay. So yeah. Yes, I'm doing it manually, and I make my problem now. I'm making many times, and really take me a lot of time because
That's why I suggest Circuit Lab. That's why I suggest Circuit Lab. Do it online.
Yeah, that's what's better now.
Because when you erase and then you do it again, it's gonna cost you a lot of time.
A lot of time, yeah.
A lot of
that's
time.
my problem. Yeah. That's why. Otherwise, I'll finish first. Okay, thank
All
you
right.
so much. I really appreciate
All right.
it. Thank you. Bye.
All right. Bye.
Bye. Thank you.